49, and they further told you that xy itself has a value of 10. So you do a substitution 2 times of 10. So 49 equals to x squared plus 2 times of 10 plus y squared. And then you rearrange, make x squared plus y squared the subject, you get 29. Because 29 plus 20 gives you 49. Okay, so that's how we get x squared plus y squared, without actually finding the individual values of x and y. So for question 4a part 1, expand and simplify. Okay, so x squared minus our bracket of x plus 2, x minus 2. This portion over here, you have to recognize that it is a special product. A plus b, a minus b. Okay, so this straight away gives us x squared minus 2 squared. This portion. Of course, you could do it like this, x squared minus, then open a big bracket, wow, then you do them step by step, x squared minus 2x, x squared minus 2x, then 2 times x plus 2x, then hey, they disappear, 0. And then you have 2 times negative 2, minus 4. Isn't it the same? X squared minus 4, x squared minus 4, straight away. So put them back into the equation. X squared minus 2 squared. So you expand this bracket. Negative x squared. X squared minus x squared disappear. Negative times negative 2 squared. You get 4. Positive 4. And then in part 2, it's actually the same thing. X squared minus y squared. So we recognize that x plus y, x minus y is our x squared minus y squared. So that makes our job a lot more simpler. So using our answers from part A, write down the value of 99,999 minus, what is that? 100,002 times 99,996. Okay, so we recognize again that it is of the form. It has the same format as what we had in part A, before expansion. Okay, so let me put it down for you. In part A, we found that I'll remove all these first, yeah. In part A, x squared minus x plus 2, x minus 2. We found that this was the same as simply, oh no, what do we have? 4. Okay, then in part 2, we found that x squared minus x plus y, x minus y was simply equal to y squared. That was the result. Then we do a comparison. X squared with our 99999 square. You do a comparison for the next section. Minus sign, followed by x plus y with this, and this with this. Can you then identify what should our x be and what should our y be? Do a direct comparison. Okay, so clearly our x is going to be 99,999. That is our x value. Okay, if that is our x value, then what should our y value be? So now we have to compare the second portion. Okay, we have already let x be 99,999. So 99,999 plus a y plus something gives us 10,002. So based on this, if x is equal to 99999, then our y value must be equal to 3, isn't it? Because 99999 plus 3 gives us 10,002. Okay? Then we confirm it with the last term over here. Now if x is 99999 and y is equals to 3, when you subtract them, you do get 99996. So all this points to our x being having the value of 99999 and y equals to 3. Then based on that, we actually don't have to evaluate, we can find out based on part 2. Hey, the answer is just y squared. And we decided that y is equals to 3. Therefore, the answer is simply 9. 3 squared. Okay, so we could skip, let me see, let y be equal to 3, and then the answer will simply be just 3 squared, which is 9. Okay, so hence questions, you have to search for the relationship between the first part of the question and the second part of the question. You cannot use your calculator to evaluate. Alright, next. Manipulation of algebraic expression, 1a. I don't think there are any major issues with this. Check your final answer. Just want to highlight a point that since you are introducing the square root symbol, you have to put a plus minus. Make sure you have that. So I'm not going through this, part A. And for part B, look, they gave you a clue already. Find the values. There could be there could be more than one. And that happens because there is a plus minus sign. Okay, so this is the value. Then round it off to 3SF. Sorry. Equals to whatever value they round off to the two answers. One positive, one negative. And then for question 2, we've done this in last year already. We've done the same question last year already. Very popular question though. So put a star. Make sure you know how to do this. To make u the subject versus 1 over f equals to 1 over u plus 1 over v. Then you go around thinking that f equals to u plus v and therefore u equals to f minus v. This is wrong, Next one, 3a. Okay, just a simple substitution and simple rearranging. So just check your final answer. This particular square root symbol was given to us. You were not the one who introduced it. It was given to you. It is a positive square root because there isn't a minus sign. So it is positive square root. Alright, moving on. Question 9. Solving linear equations. Guaranteed, guaranteed will have simultaneous equation that you have to solve in your media exams. So you let one equation be equation number 1, let the other equation be equation number 2. Now they specified that they want you to use substitution. So based on equation 1 and equation 2, we are trying to find the equation that has one of the variables coefficient equal to 1. In this case, equation number 1 has the coefficient of y to be 1. We want to use that because we want to make something the subject. You need to make either x or y the subject for substitution. And we always go around searching for the variable that has coefficient 1 so that we save some effort on our end. No need to go and divide. Imagine if you chose, let's say equation 2 from number 2. Then you try and make x the subject. 2x equals to 17 minus 3y. X equals to 17 minus 3y over 2. And you substitute this into equation number 1. Can you imagine substituting this fraction inside here? You're just giving yourself a lot more work. So you might as well choose from equation number 1, y is already has a coefficient of 1. So just make y the subject. And then you substitute this linear expression inside equation number 2. Make your job easier, no fraction involved. Okay? Then from there, you will find that it is just one equation with one unknown. That is the whole idea of substitution. Get a x value, substitute it into equation number 3, and get a y value. So conclude by stating the x and y value at the final line. So pretty straightforward for this question. Now for question 2, they want you to do it by elimination. So same thing, you always start off your simultaneous equation with equation number 1 and equation number 2. Now we need to use elimination, which means that the coefficient of x, of both x's, must have the same magnitude. Either 5 and 5, 2 and 2, negative 2 and 2, negative 1 and 1, so on and so forth. Same magnitude. I didn't say the same sign. Okay, the coefficient, the magnitude of the coefficient of either one of the values must have the same magnitude. So let's take a close look at this. Compare 3 and 7, the x coefficients. And then you compare negative 10 and negative 2. Is it easier to make the coefficients of x to be the same? Or is it easier to make the coefficients of y to have the same magnitude? In this case, it is clear. We would rather make the coefficients of y to have the same magnitude. Because then the magnitude will be 10. All we need to do is to take equation number 2 times 5. Because when you multiply everything by 5 over here, I am going to end up with 35x minus 10y. Minus 10y, isn't it the same as equation 1? If they are the same, I can proceed with my elimination. Compare that to, if I didn't do that, if I chose to make the coefficients of x to be the same magnitude, then I will need to take equation number 1 times 7, equation number 2 times 3. Then I would have coefficient of x to be 21. It will work, but you're just giving yourself extra work. More room for careless mistakes. So we don't want that. Not a good idea. Okay, so when you multiply equation 2 by 5, this is what you will end up with. And now we can throw away our equation 2 already. We have made use of it. We have transformed it to a form that we prefer. So now we have equation 3. We compare that with equation number 1. Since the coefficients of y are the same. If they are the same, elimination happens by subtracting. Okay, so we subtract equation 3 minus equation 1, or equation 1 minus equation 3, doesn't matter. Now if the coefficients happen to be negative 10 and 10, so one positive, one negative, how do you eliminate? Negative and positive, you add them together, they disappear. Okay, so different sign, but same magnitude. For example, negative 10 and 10, you add them together to eliminate. But if it is the same sign, such as negative 10 and negative 10, we will need to subtract them. If it is positive 10, we need to subtract them. Okay? It is always subtract unless the signs are opposite. Then you add to eliminate. So taking equation 3 minus equation 1, we take the entire left-hand side of equation 3. The entire left-hand side of equation 3 minus the entire left-hand side of equation number 1. So that is shown over here. Left-hand side of equation 3 minus left-hand side of equation 1. Notice that I put a bracket. Important, because that's where the next mistake could happen. If you do not put a bracket, your next step would end up with minus, with the bracket it will be minus negative 10. Why? So positive 10y. With the positive 10y, you add that to negative 10y, then your y term is eliminated. Imagine if you didn't put a bracket. If you didn't put a bracket, this is what it looks like. Then you see negative 10y minus 10y. Oh, now I end up with negative 20y. And then you still have x term. You didn't eliminate anything. That means something is wrong already. Most likely it happened because you forgot to put a brackets over here. So left hand side done, right hand side, equation number 3 minus the right hand side of equation number 1, which was 11. Okay, do the subtraction, expansion, get an x term, substitute, and get a y term. Definitely, you need to know how to do this. Huh? It will be tested. Either elimination or subtraction. Maybe both. Maybe they'll specify. So you need to be familiar with both of them. Alright, we've come to the last two pages. For 10A, page 11, question 1A. Simplify the following. Algebraic fractions. Okay, so do it bit by bit. I'll explain it out for you. Negative 2 square, 3 square, AB square, C cube, 3A cube, B square, C square. Notice that I cancel all things, right? You can do so also. But please use a pencil so that when it gets too complicated, too messy, you can erase, you can start over again. If you use a pen, you're just setting yourself up for trouble. Let's start with the numbers first. Always start with the numbers first. So 3 square and 3, cancel, cancel. So no more 3 at the denominator. No more power 2. It is just 3 power 1. So we don't bother writing it down. Let's talk about the A term. The variable A. There is one A on top, there are 3 at the bottom. We can cancel one of them. So left with 2 at the bottom. We can cancel both of the B squares. We can cancel C 2 times. Because it appeared 3 times in the numerator, twice in the denominator. Cancel, cancel. What is left? Negative 2 squared, we get 4 times 3, 12. That's the number, numeric value. Variable wise, in the numerator, we only have C left. In the denominator, no more numbers. We only have A squared left. As simple as that. Now in part B, simplify again. At first glance, there is nothing to simplify. Nothing to expand on. But turns out that there are common factors that we can cancel again. Okay, so let's start with the first one. 5p squared minus 45q squared. There is a 5 that is common factor. So you take that out, factorize it out. 5p squared minus 9q squared. So this 9 over here, yesterday I emphasized again, you must be sensitive to perfect squares. Your 4s, your 9s, so on and so forth. Because this is not a perfect square. It is no coincidence that we have p squared minus another perfect square. This is the case of x squared minus y squared, or a squared minus b squared, where it will be rewritten to be p minus 3q, p plus 3q. This is our factorization of a squared minus b squared. So you may be thinking, wait, why is something so simple? 5p squared minus 45q squared. You make it so complicated. Factorize out this way. Well, the reason is because in the denominator, we can factorize it again. P plus 3q multiplied by p. And we see the same p plus 3q appear. Then we can cancel. And now it is simplified to become 5p minus 15q over p. It is the simplified version now. It's compared to the original. Instead of squares, power 2s, no more already. It is now simpler. Next, part C, same thing. If you see a power 2, when they ask you to simplify with a power 2, always try and factorize. So x squared plus 2x minus 8, and use your calculator. And I actually encourage you to practice until you get it. So for me, equation, then polynomial, degree 2, I will key in x. Coefficient x squared is 1, key in 1, equal. Coefficient x is 2, 2, equal. The last term is negative 8, press negative 8, equal. I'm going to press equal again. Whatever that appears, I'm going to switch the sign. Okay, so if I see the calculator says 2, I will factorize it to become x minus 2. If the calculator says minus 100, then I will write x plus 100. Okay, so let's see. Oh, it says 2. So I will write x minus 2 over here. Whether you put it in front, behind, doesn't matter. But calculator says 2, means there is an x minus 2 term. Calculator says negative 4. It means there is a x plus 4 in the denominator. Okay? So in the case of factorization, you can use your calculator to help you. Just need to be very careful when the coefficient of x squared is not 1. When it is not 1, let's say it is negative 2, 5, 10, then we covered it yesterday already. You will end up with a fraction. Okay, then same as what Aloysius did yesterday, just figure out how to map it back to the original. Okay, now in the numerator we have factor of 5, so x minus 2, and we see that we can cancel again. And that's how we simplify. Okay, this factorizing, you can of course use your box again lah. The next one, 2a, expressed as a single fraction, simplest form. Primary school teachers say denominator must be the same, then you can add them up. Please do not go and multiply all of them to each other. You're going to end up with a power 3. Not simple anymore. 4x squared, 4, be sensitive to it. 9, be sensitive to it. Because we actually have 4x squared minus 9 to be 2x plus 3, 2x minus 3. It is now factorized to this form. Came from your 4x squared minus 9. Okay, this is the rewritten form of the original denominator. So 2x plus 3, 2x minus 3. On numerator 4, no change. And we see that in the other denominator, 3 minus 2x, very similar. 3 minus 2x and 2x minus 3. Almost the same, right? So how do we convert one to the other? Okay, I will change this. Please don't copy this. Although it is correct, it is correct, but I don't want to write that anymore. I want to change the second denominator. So I'll copy the first one, 4 over 2x plus 3, 2x minus 3. The second denominator, instead of 3 minus 2x, I want to change it to become 2x minus 3. Okay, so still a 1 plus. But can you see that now the right hand side, they are different? Not equal, right? I want to do a change. Put a minus sign. Now the denominators are the same. Compare them. 3 minus 2x versus negative 2x minus 3. Same. Okay. Now, I am happy to see that this has appeared. Now, I don't want this negative sign. Let's get rid of it. How do we get rid of it? You just remove this negative sign, put it over here. Why can we do that? How come we can do that? Well, this was initially a plus, this was a minus. To get rid of this, I multiply by negative 1, I multiply by negative 1. Okay, when multiply by negative 1, disappear. So numerator is minus 1. Now, plus negative 1 over 2x minus 3 is the same as putting this as a minus, and numerator is just a plus. Okay, so this is what we have. In summary, if you want to change the sign in the denominator, just change the sign here. That's the summary. Now, denominator almost the same already, but I still need to multiply with 2x plus 3, 2x plus 3 over here. Then I can combine. So 4 minus 2x plus 3, 2x plus 3 over 2x plus 3, 2x minus 3. So in our numerator, now is the time to expand. 4 minus 2x minus 3, 2x plus 3, 2x minus 3. So 1 minus 2x. Okay, so this is the answer. Now in part B, Similarly, make the denominator the same. So on the fraction on the right hand side, you need to multiply both numerator and denominator by x minus 3, so that the denominators on both fractions are the same. Then you can apply your primary school mathematics, get the answer. So it's more straightforward lah. And now part C. Look, denominator is a y squared. The other is a y minus 2. You do not multiply both of them together to end up with y cubed. It is not simple anymore. So you need to factorize, okay? You can use this to factorize. Or you can use your calculator. Again, I'll demonstrate. Coefficient of y squared is 1. Coefficient of y is 1 again. Coefficient, the last one, constant value is negative 6. Your calculator shows 2. So you write y minus 2. Next, your calculator is going to show negative 3. So you write y plus 3. Switch the signs. And turns out, y plus 3, we can cancel them. So left with 1 minus 3y over y minus 2. Okay, any questions? Then the last page. Okay, 2y plus 5x is 8. Find the gradient and y-intercept. So this is a straight line. How do we confirm? You make it y equals to mx plus c. So in summary, make y the subject. Y equals to m. This is our gradient. The coefficient of x is our gradient. The constant term is our y-intercept. So it's just one step. Not much calculation to do. Okay, then for question 2, find the gradient of a line. When you're given two sets of coordinates, gradient, you can do it as rise over run, y2 minus y1 over x2 minus x1. Either way, you will end up with negative 5 over 6. You can plot it out on the x and y axis to have a better idea of where it is. This is our point A, negative 2, 0, and our point B, 4, negative 5. 4, negative 5. Okay, then draw a triangle, do your rise over run, starting from the bottom. You rise up by how many units? Then you run to the left by how many units? So that's the gradient. Okay, I think the bell is going to go soon already. So we'll leave question, the number pattern for tomorrow. Okay?